And then you guys can finish up that quiz and work on ethics all the rest of the period. All right, so chapter 7 is all about hypothesis testing. In 7.1, we're not actually going to do any hypothesis testing. What we're going to be doing is all the little pieces and parts that you need to know to be able to do a hypothesis test, which is we'll put all these pieces together in section 7.2 eventually. Okay, so for right now, it's going to seem kind of like segmented, and it's not really going to make a whole lot of sense how all these pieces fit together, but in a couple days, we'll kind of put it all into one big problem. All right, so a hypothesis test is a process that uses sample statistics to test a claim about a value of a population parameter. So we talked in chapter 6 when we were doing confidence intervals about population parameters. It could be a mean, mu, or it could be the p hat and p, that is our proportions. We talked a lot about those. We could also have population parameters that are variance or standard deviation. We didn't do a lot of confidence intervals with those, but you could, okay? Same with hypothesis tests. We're going to see a lot of hypothesis tests. Mostly we're going to focus on population mean, is what we're going to be making hypotheses about. And then proportions as well, but you might also see like a standard deviation or a variance thrown in there also. Okay, when we do a hypothesis test, we make a claim about something, and the claim will have a mathematical statement in it somewhere. It's going to say less than, greater than, equal to, not equal to, whatever. And there's going to be two parts that make that up. The claim will either be a null or alternative hypothesis, and then the complement of our claim will be the other one. So we will always start a hypothesis test with two hypotheses, the null and alternative. And that's really what our lesson today is going to focus on, is how to write a null and alternative hypothesis, which are going to start these big tests that we're going to do. All right, so what are they? So a null hypothesis, which H null or H sub 0 is how we would say that, is a statistical hypothesis that will contain some sort of statement of equality. So these statements, sometimes they'll be a claim, will be less than or equal to, or greater than or equal to. One of those three symbols will always be in our null hypothesis and statement of equality because they all have an equal to piece in them. Then we have an alternative hypothesis, which is H sub A, and this one does not have a statement of equality. So these are just strictly our less than, greater than, and not equal to statement. So if you're not sure which hypothesis you're looking at, you can look at the mathematical statement. If it has an equal to piece in it, it's a null. If it's not equal to, it's an alternative. Like I mentioned, either of those could be the claim, but what's going to remain the same throughout all of these is that they will always be complements of each other. So what we're going to do on these little number lines is I'm just going to kind of show you how we know that these sets are complements of each other. These are kind of our three scenarios that we're going to see when we write our hypotheses. And I'm actually going to start at the bottom and work my way up. Okay. So at the very bottom, we have a null hypothesis, H sub 0, that says the mean, population mean of something is greater than or equal to 15 minutes. And then the alternative hypothesis, which is the claim that someone is making, is that the mean of whatever is less than 15 minutes. Okay, and we're going to graph both of these. So I'm going to find 15 minutes somewhere on my number line. I'm just going to stick it in the middle there. And I'm going to graph my alternative hypothesis first. So it's that the mean is less than 15 minutes. So we're just going to go back to like algebra 1. I'm going to make an open circle at 15, meaning not equal to, and I'm going to shade everything to the left. And that is my alternative hypothesis. Okay. Then the null hypothesis in this example is that the mean is greater than or equal to 15 minutes. So I'll just graph this one right above it. This would be a closed circle at 15. And then we would shade to the right. And we call them complements of one another because between the two shading intervals that you see there, we've covered our whole number line. We've covered all possibilities. Okay, so you can see everything's included in that number line. Okay, the one above it, the claim is again the alternative hypothesis that the mean is greater than 18 years. So I'm going to find 18 on there somewhere. Open circle at 18, shade to the right. That is my alternative hypothesis, just greater than 18. The null for this one is that my mean is less than or equal to 15 minutes. Shade to the left. And again, my whole number line is included in those two regions. Okay. The last one is a claim being made about a proportion, P, that we saw in our last chapter. The claim is that the proportion of something is 0.61, which means 61%. So they're claiming that 61% of people maybe did this one thing, whatever that is. All right, so what we do is we find 0.61 in our number line, and the claim is that we're equal to 0.61, so it's just a single point. That's it. That's my null hypothesis, okay? And then the alternative hypothesis is that it's not equal to 0.61. So we just need to make sure everything else on my number line is included. So that's going to look like, should have given myself a little extra space there, an open circle at 0.61, but then everything else would be shaded on the number line left and right. And that would be the alternative hypothesis in this case. Okay, so again, this is a nice picture too. You can see every time I've graphed that null hypothesis, I have a solid dot it's equal to. Every time I've graphed that alternative hypothesis, it's an open dot not equal to. Any questions on those? Okay, next up. All right, what they're giving us in each of these is a claim. We need to decide if the claim is a null or alternative hypothesis, and then once we know that, we're going to write the other one. Okay, so the first one, what's that symbol for, the little sigma squared? What's that mean? Variance. Okay, so this is a claim about variance. So it's saying the variance of something is greater than or equal to 1.2. That's the claim. Can you tell me, is that a null or alternative hypothesis? That is a null hypothesis. How do you know? Because it's equal to, okay? So then our job is to write the alternative hypothesis, okay? So we're either greater than or equal to 1.2, or what's the alternative? Less than 1.2. So it's still variance. It's still 1.2. The only thing that changes is our inequality symbol. All right, the one in the middle, what's a claim being made about? What population parameter? What's that symbol for? Standard deviation. Okay, so it says standard deviation of something is not equal to 5. Is that a null or alternative hypothesis? This time it's an alternative hypothesis because it's not equal to. So what would the null hypothesis be then? You're either equal to or not equal to, right? So equals 5. Perfect. Okay. All right, and then the last one, we are making a claim about what? What's P stand for? P stands for? We did it in the last section. P stands for a problem. I mean, it is a problem right now if we don't know what it stands for. Probability, close. That's where you're going with that. Proportion? Yeah? Okay, it's a proportion. Okay, so it says the proportion is less than 45%, 0.45. Is that a null or alternative? Alternative. So the null would be what? That the proportion is greater than or equal to 45%. Okay, any questions on that? Great. Okay, so often with these problems, you won't be given things with mathematical symbols. It's going to be in word problem format, and you're going to take that word problem and essentially translate it into those mathematical symbols. These are all the different ways that, ways, key phrases that you might see these written, kind of things that you want to focus in on the word problem. And remember, what they're claiming could be a null or alternative. So you might see something from the left side, or you might see something from the right side. But once you get one, you can always get the other. So this chart is just meant to kind of help you kind of sort through the word problem. If you see something and you're not sure how to translate it into the mathematical statements, there are still those same 3 sets that we graphed with our number lines. But now we've got it kind of superimposed on top of this chart where you can kind of see what those phrases that coincide with them would look like. So go ahead and take a second and fill those in the boxes on your paper. Okay. And again, if you're getting something from the left column, it's telling you the null hypothesis. And from that, you can get the alternative. If it's giving you something from the right column, it's telling you the alternative hypothesis, and from that you can get the null hypothesis. All of these are written in terms of a mean, but it might not be a mean. It might be a variance or standard deviation or proportion or something else that we're making a claim about. This is just our most common one that we see. Okay, everybody got them? All right, so let's practice now. Each of these is a claim that we want to write as a mathematical statement, label it as the null or alternative, and then write the other one. All right, so number one says, a consumer analyst reports that the mean life of a certain type of automobile battery is not 74 months. Okay, so you want to know what you're making the claim about. They're making a claim about a mean. Okay, so that's the variable that we're going to use in this one. I'm going to label it as the claim with a little space there. It's telling me that the mean life of a battery is not 74 months. So what mathematical symbol are we going to use? Not equal to 74. If it's not equal to, is it a null or alternative hypothesis? It is an alternative. Okay, so I've labeled the claim, I've written the claim. Now I need to write the other hypothesis, that is its complement. The null hypothesis would be what? Mean is equal to 74. Okay, number two. An electronics manufacturer publishes that the variance of the life of its home theater systems is less than or equal to 2.7. All right, is this claim going to be a null or alternative hypothesis? What do you think? It's going to be a null because it contains the word equal to. Less than or equal to. Variance is my sigma squared, less than or equal to 2.7. And then if I have the null, I can write the alternative, the variance, sigma squared. If it's not less than or equal to, what is it? Greater than 2.7. Okay, and then last but not least, number three. Number three says a realtor publicizes that the proportion of homeowners who feel their house is too small for their family is more than 24%. Is the claim a null or alternative hypothesis? Alternative. And for proportion, we use a P. Is more than, so greater than, and when we write proportions, we always use that decimal, so just 0.24. Okay, so then the null hypothesis for my proportion would be if I'm not greater than, what am I? Less than or equal to 0.24. Okay, any questions? All right, the last slide is yours to try. I want you to do the same thing as we did on the last slide, okay? So write the null, write the alternative, and label which of the two is the claim. And then we'll put them up on the board and check them. All right, let's check them. Probably the one that's missed the most is the last one because of how it's worded. So the claim is that 73% of people did a thing. In this case, they did not use their student loan or did not use student loans to pay for college. Okay, so the claim is that the percent is 73% that did that certain thing. Okay, so this did not is not the percent not equal to, it's that they just didn't use college folks. So be careful with that. That's a common mistake, just to switch the equal to not equal to on that one. Which one's the null and which one's the alternative? The other three are pretty straightforward though, I think. Okay, so that's as far as we're going to go into 7-1 today. Like I said, the Math Excel, you should be able to do all the 7-1 day 1 Math Excel. It's just a lot of multiple choice and like drop down stuff. You can see there's nothing we really did any calculations with, so it should be pretty quick for you, okay? So I'm going to pass back now your quiz from Friday. Give you like another 15 minutes or so. If you're done with it, you can just put it right back in the tray, and then the rest of the period is yours to work on your Math Excel. Tomorrow we'll go into the next section, and I'll do cell phone model for you, okay? All right. Remember, you can use your notes, use your graphing calculator, technology for this piece, okay?